If the points -1, 2, -3 and 4a1 and b8, 5 are collinear, then a and b are respectively equal to option A 5 and 5, B 9 and 5, C 5 and 9, D -5 and 9. Since the points are collinear, therefore we get x2 minus x1 is equal to x3 minus x2 and y2 minus y1 is equal to y3 minus y2. Substituting the values, we would get b minus 4 is equal to 4 minus -1 and a minus 2 equal to 8 minus a, where b is equal to 9 and 2a is equal to 10. Therefore a is equal to 5. Hence we get a is equal to 5 and b is equal to 9. So the correct option is C. Question number 2. The triangle formed by the points 0, 7, 10, -1, 6, 6, -4, 9, 6 is equilateral triangle, isosceles triangle, right angled isosceles triangle. Okay, let AB points 0, 7 and 10, BB -1, 6, 6 and CB -4, 9 and 6. Okay, then AB is equal to under root 1 plus 1 plus 16, which is equal to under root 18 equal to 3 under root 2. Similarly, BC is equal to 9 plus 9 plus 0 equal to under root 18, which is equal to 3 under root 2. Similarly, AC is equal to 16 plus 4 plus 16 is equal to under root 36 is equal to 6. Thus, it is clearly proved that AC square is equal to AB square plus BC square. Also, AB is equal to BC. Therefore, triangle is right angled isosceles. Therefore, the correct option is D. The pairs of rectangular coordinates planes have equation option A xy is equal to yz is equal to zx is equal to 0. Option B x is equal to y is equal to z is equal to 0. Option C xyz is equal to 0. And option D none of these. We all know that the pair of rectangular coordinates planes have equations xy is equal to 0, yz is equal to 0 and zx is equal to 0. Therefore, the correct option is option A. The points A having coordinates 1, 0, 1, point B having coordinates -1, 2, 3 and point C having coordinates 0, 1 and 2 are non-collinear, collinear, non-coplanar or none of these. Okay, we know that here AB is equal to 2 under root 3, BC is equal to root 3, and AC is equal to root 3. Okay, because AB is equal to AC plus BC. So nothing that presentation A, B and C. So here we get root 3, here we get root 3. Therefore, these points are collinear. Question 5. The shortest distances of the point 1, 2, 3 from the axis XYZ respectively are option A 1, 2, 3, option B under root 5, under root 13, under root 10, option C under root 10, under root 13, under root 5, option D under root 13, under root 10, under root 5. Okay, so the distance from x-axis is equal to under root of y square plus z square. So substituting the values, we would get 4 plus 9, it's equal to under root of 13. Similarly, for y-axis, it would be x square plus z square. Substituting, we would get root of 10. Similarly, for z-axis, we would get x square plus y square, which would result in root of 5. So here the value of x is root of 13, y is root of 10, and z-axis is root of 5. So the correct option is option D. Question number 6. If point A having coordinates 1, 2, minus 1 and point B having coordinates minus 1, 0, 1 are given, then the coordinates of P, which divides AB externally in the ratio 1:2 are A 1 by 3 times 1, 4, minus 1, option B 3, 4, minus 3, option C 1 upon 3 times 1 by 3 times 3, 4, minus 3, D none of these. Okay, substituting it to the form 2 plus 1 upon 1, comma 4 minus 0 upon 1 and minus 2 minus 1 upon 1. Here this would result into 3, 4 and minus 3. So the correct answer is option B. A line makes angle alpha, beta, gamma with a coordinate axis. If alpha plus beta is equal to 90 degrees, then gamma is equal to option A 0 degrees, option B 90 degrees, option C 180 degrees, option D none of these. We know the formula cos square alpha plus cos square 90 minus alpha plus cos square gamma is equal to 1. Okay, further solving it, square alpha plus sin square alpha plus cos square gamma is equal to 1. Thereby we get cos square gamma plus 1 is equal to 1. Therefore, gamma is equal to 90 degrees. Therefore, the correct answer is option B. Question number 8. A line AB in 3-dimensional space makes angle of 45 degrees and 120 degrees with a positive x-axis and positive y-axis respectively. If AB makes an acute angle theta with positive z-axis, the theta equals to option A 30 degrees, option B 45 degrees, option C 60 degrees, option D 75 degrees. Here we know the formula cos square alpha plus cos square beta plus cos square gamma is equal to 1. Here we know that alpha is equal to 45 degrees and beta is equal to 120 degrees. We put these values in the above equations, we get as 1 upon 2 plus 1 upon 4 plus cos square gamma is equal to 1. Therefore, cos square gamma is equal to 1 by 4. Therefore, gamma is equal to 60 degrees. So, the correct option is option C. Question number 9. If projection of any line on coordinate axes 3, 4 and 5, then its length is option A 12, option B 50, option C 5 times root 2, option D 3 times root 2. Let D be the length of line. So the projection on x-axis be denoted by dl, which is equal to 3. Projection on y-axis be denoted by dm, which is equal to 4. And projection on z-axis be dn, which is equal to 5. Now, putting the formula d square is equal to l square plus m square plus n square would result into 50, which is equal to d square. Therefore, we would get d is equal to 5 times root 2. So, the correct answer is option C. Question number 10. The direction ratios of the line joining the points 4, 3, minus 5 and minus 2, 1, minus 8 are option A 6 by 7, 2 by 7, 3 by 7, option B 6, 2, 3, option C 2, 4, minus 13, D none of these. Let the direction ratios are L is equal to 4 minus 2, which is equal to 6. M is equal to 3 minus 1, which is equal to 2. And N equals to minus 5 plus 8 is equal to 3. So, the correct answer is option B. Question number 11. The coordinates of the point in which the line joining the points 3, 5, minus 7 and minus 2, 1, 8 is intersected by the plane YZ are given by option A 0, 13 by 5, 2, option B 0, minus 13 by 5, minus 2, option C 0, minus 13 by 5, 2 by 5, option D 0, 13 by 5, 2 by 5. Okay, so we get it to the formula of ratio, which is equal to minus 3 by minus 2, which would result in 3 by 2. So the required coordinates of the point would be 6 minus 6 upon 5, comma 10 plus 3 upon 5, comma minus 14 plus 24 upon 5. So further calculating, we would get 0, 13 by 5 and 2. So the correct option would be option A. If the straight lines x minus 1 upon k is equal to y minus 2 upon 2 is equal to z minus 3 upon 3, and x minus 2 upon 3 is equal to y minus 3 upon k is equal to z minus 1 upon 2 intersect at a point, then the integer k is equal to minus 5, 2, minus 2 and minus 5. Okay, so because these lines are intersecting, we have a matrix that would be like x2 minus x1, y2 minus y1, z2 minus z1, then L1, M1, N1, L2, M2, N2, which would result to be 0. So therefore, substituting these values, we would get 2 minus 1, 3 minus 2, 1 minus 3, k 2, 3, 3, k 2. Thus, simplifying this, we would get 1, 1 minus 2, k 2, 3, 3, k 2. We get the equation 2k square plus 5k minus 25 is equal to 0. Factorizing this equation, we would get k is equal to 5 by 2 and minus 5. Therefore, the correct option is minus 5, that is option D. Question number 13. The angle between the lines whose direction cosines satisfy the equation L plus M plus N is equal to 0 and L square plus M square minus N square is equal to 0 is given by 2 pi by 3, pi by 6, 5 pi by 6, pi by 3. Okay, since L plus M plus N square is given, let's consider it equation 1. L square plus M square minus N equation 2, and we also get L square plus M square plus N square is equal to 1. Let's consider it equation 3. Now solving these above equations 1, 2 and 3, we would get M as plus minus 1 by root 2, N would be plus minus 1 by root 2 and L is equal to 0. Therefore, solving them, we would get theta as pi by 3 or pi by 2. So pi by 3 is the correct answer. So here option D is the correct answer. Question number 14. The equation of straight line passing through the points A, B, C and A minus B, B minus C, C minus A is option A, x minus A upon A minus B is equal to y minus B upon B minus C is equal to Z minus C upon C minus A. Option B, x minus A upon B is equal to y minus B upon C is equal to Z minus C upon A. Option C, x minus A upon A is equal to y minus B upon B is equal to Z minus C upon C. Option D, x minus A upon 2A minus B is equal to y minus B upon 2B minus C is equal to Z minus C upon 2C minus A. Here the required line is x minus A upon A minus B minus A, which is equal to y minus B upon B minus C minus B, which is equal to z minus c upon c minus a minus c. That is x minus a upon b, which is equal to y minus b upon c, which is equal to z minus c upon a. Therefore, the correct answer is option B. Question number 15. If the lines x minus 1 upon minus 3 is equal to y minus 2 upon 2k is equal to z minus 3 upon 2 and x minus 1 upon 3k is equal to y minus 5 upon 1 is equal to z minus 6 upon minus 5 are at right angles, then k is equal to minus 10, 10 by 7, minus 10 by 7 or minus 7 upon 10. If lines are perpendicular, then we would get a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Hence, substituting the values, 3k plus 2k times 1 plus 2 minus 2 times minus 5. We know that this is equal to 0. Therefore, further solving it, we would get k is equal to minus 10 upon 7. So, the correct answer is option C. Question number 16. Distance between two parallel planes 2x plus y plus 2z is equal to 8 and 4x plus 2y plus 4z plus 5 is equal to 0 is option A 9 by 2, option B 5 by 2, option C 7 by 2, option D 3 by 2. Now solving them, we get that the given planes are 2x plus y plus 2z is equal to 8 and 4x plus 2y plus 4z 2z equal to 8 and 4z is distance between two parallel planes is given by further solving this, we get 21 upon 6, which can be further simplified as 7 by 2. So, the correct answer is option C. Question number 17. The value of k for which the planes 3x minus 6y minus 2z is equal to 7 and 2x plus y minus kz equal to 0 are perpendicular to each other is option A 0, option B 1, option C 2, option D 3. So if these planes are perpendicular, simplifying these equations, we would get 6 minus 6 plus 2k is equal to 0 because we're considering them as perpendicular. So further simplifying this, we only get k is equal to 0. So the correct answer is option A. K is equal to 0. Question number 18. Distance of the point 2, 3, 4 from the plane 3x minus 6y plus 2z plus 11 is equal to 0 is 1, 2, 3 or 0. We know that the required distance can be obtained using the formula. So substituting the values directly, 6 minus 18 plus 18 plus 11 upon 7, we would get it as 1. So the correct answer is option A, 1. Question number 19. A plane making intercepts of length 1, 2 and 3 on the rectangular coordinate axis is represented by the equation A x plus y by 2 plus z by 3 is equal to 1. Option B, x plus 2y plus 3z is equal to 1. Option C, x minus 1 is equal to y minus 2 is equal to z minus 3. Or option D, none of these. We know that the formula x upon a plus y upon b plus z upon c is equal to 1. This is the equation formula for intercepts. So substituting the values, we get plus z by 3, which is equal to 1. So the correct option is option A. Question number 20. The equation of the plane passing through the intersection of the planes x plus y plus z is equal to 6 and 2x plus 3y plus 4z plus 5 is equal to 0. The point 1, 1, 1 is option A. 20x plus 23y plus 26z minus 69 is equal to 0. 20x plus 23y plus 26z plus 69 is equal to 0. 23x plus 20y plus 26z minus 69 is equal to 0. Option D, none of these. So solving the intercepts, we would get x plus y plus z minus 6 plus delta 2x plus 3y plus 4z plus 5 is equal to 0. So we get lambda as 3 by 14. So the correct answer is 20x plus 23y plus 26z minus 69, which is equal to 0. So the correct answer is option A. Question number 21. The ratio in which the plane x minus 2y plus 3z is equal to 17 divides the line joining the points minus 2, 4, 7 and 3, minus 5, 8 is in the ratio 10 is to 3, 3 is to 1, 3 is to 10, 10 is to 1. Using the formula of the ratio, we would get minus 2 minus 8 plus 21 minus 17 upon 3 plus 10 plus 24 minus 17. Solving above, we would get minus 6 upon 20, which would be further simplified as 3 by 10. So the correct answer is option C, 3 is to 10. Question number 22. XOZ plane divides the join of 231 and 671 in the ratio 3 is to 7, 2 is to 7, minus 3 is to 7, minus 2 is to 7. So we know that the XOZ plane divides the join of 231 and minus 671 in the ratio of minus y1 is to y2. So we know that the values of minus 1, 1 and y2 are minus 3 is to 7. So the correct answer is option C, minus 3 is to 7. Question number 23. The equation of the plane passing through the origin and perpendicular to the plane x is equal to 2y is equal to 3z is 6x plus 3y plus 2z is equal to 0. Option B, x plus 2y plus 3z is equal to 0. Option C, 3x plus 2y plus z is equal to 0. Or option D, none of these. The line would be x upon 6, that is equal to y upon 3, which is equal to z upon 2. So the required plane is 6 into x minus 0 plus 3 into y minus 0 plus 2 times z minus 0. So from this we know that the correct answer would be 3x plus 3y plus 2z is equal to 0. So the correct answer is option A. 3x plus 6x plus 3y plus 2z is equal to 0. Question number 24. If the equation of a line and a plane be x plus 3 upon 2 which is equal to y minus 4 upon 3 which is equal to z plus 5 upon 2 and 4x minus 2y minus z is equal to 1 respectively, then the line would be parallel to plane, perpendicular to plane, lies in the plane, or none of these. So let us solve this. So we would get 4 to 2 minus 2 by 2 times 3 minus 1 by 2. So here solving this we get answer as 0. Therefore the lines are parallel to the plane. So the correct answer is option A. Question number 25. The equation of the line passing through the points 1, 2, 3 and parallel to the planes x minus y plus 2z equals to 5 and 3x plus y plus z is equal to 6 is x minus 1 upon minus 3 is equal to y minus 2 upon 5 is equal to z minus 3 upon 4. Option B, x minus 1 upon minus 3 is equal to y minus 2 upon minus 5 is equal to z minus 1 upon 4. See, x minus 1 upon minus 3 is equal to y minus 2 upon minus 5 is equal to z minus 1 upon minus 4, or option D, none of these. So we know that x minus 1 upon L is equal to y minus 2 upon m is equal to z minus 3 upon n. Okay, so here we would get that as L minus m plus 2n is equal to 0 and 3L plus m plus n is equal to 0. Therefore, we get it as x minus 1 upon minus 3 is equal to y minus 2 upon 5 is equal to z minus 3 upon 4. So the correct answer is option A. Question number 26. The line drawn from the point 4 minus 1 2 to the point minus 3 2 3 meets a plane at right angles at the point minus 10 5 4. Then the equation of plane is option A, 7x minus 3y minus z plus 89 is equal to 0. Option B, 7x plus 3y plus z plus 89 is equal to 0. Option C, 7x minus 3y plus z plus 89 is equal to 0. Option D, none of these. So the required plane is 7 into x plus 10 minus 3 into y minus 5 minus z minus 4, which is equal to 0. Further, we would get it as 7x minus 3y minus z plus 89 is equal to 0. So the correct option is option A. Question number 27. The ratio in which the line joining the points ABC and minus A minus C minus B is divided by the xy plane is A is to B, B is to C, C is to A, or C is to B. Let the ratio be K is to 1. Since we are on the xy plane on Z, so we get that Z is equal to 0 on the xy plane. So we have the formula minus BK plus C upon K plus 1, which is equal to 0. So this is further simplified, so where we get K is equal to C upon B. Therefore the ratio is C is to B. So the correct answer is option D. Question number 28. The equation of the plane which bisects the line joining 2, 3, 4 and 6, 7, 8 is option A, x plus y plus z minus 15 is equal to 0. Option B, x minus y plus z minus 15 is equal to 0. Option C, x minus y minus z minus 15 is equal to 0. Option D, x plus y plus z plus 15 is equal to 0. So, using midpoint formula, we get the midpoint of points 2, 3, 4, 6, 7, 8 as 4, 5 and 5. Okay, so this lies on the line x plus y plus z minus 15, which is equal to 0. So this is the required plane. So the equation x plus y plus z minus 15 is equal to 0 is the correct answer. Question number 29. The coordinates of the point where the line x minus 6 upon minus 1 is equal to y plus 1 upon 0 is equal to z plus 3 upon 4 meets the plane x plus y minus z is equal to 3r, 2, 1, 0, 7 minus 1 minus 7, 1, 2 minus 6, 5 minus 1, 1. Okay, so the points are on the line. This is equal to r. So they are as minus r plus 6 minus 1 and 4r minus 3. So this will satisfy the plane which is x plus y minus z is equal to 3. So therefore we get minus r plus 6 minus 1 minus 4r plus 3 is equal to 3. Further simplifying this, we get minus 5r plus 5 is equal to 0. Therefore we get r is equal to 1. So the required coordinates are 5, minus 1 and 1. So the correct answer is option D. Question number 30. The distance of origin from the point of intersection of the line x upon 2 is equal to y minus 2 upon 3 is equal to z minus 3 upon 4 and the plane 2x plus y minus z is equal to 2 is root of 120, root of 83, 2 times root of 19 and d root of 78. Okay, so we know that the given equation is equal to lambda. So the plane would be 2x plus y minus z is equal to 2. So the point on the line would be 2 lambda, 3 lambda plus 2, comma 4 lambda plus 3. So we substitute in the equation 2 into 2 lambda plus 3 lambda plus 2 minus 4 lambda plus 3. So further solving this, we get it equal to 2, which further tends that lambda is equal to 1. So the point of intersection is 2, 5 and 7. Therefore, the distance from origin can be given by the formula 2 square plus 5 square plus 7 square, which is equal to root of 78. So the correct option is option D.